Hi class, today we're going to be looking at Chapter 8, problem, I believe it's problem 8.4, that's it, problem 8.4. We're going to be doing a direct labor budget and also a factory overhead budget. So share my screen with you. And you should be able to see now Cornerstone exercise 8.4, and we're going to do a direct labor budget for a service type of business. The School of Accounting at State University is planning its annual fundraising campaign for accounting alumni. This year, the School of Accounting is planning a call-a-thon and will ask Beta Alpha Psi members to volunteer to make phone calls to a list of 5,000 alumni. The Dean's office has agreed to let Beta Alpha Phi use their offices from 6 to 9 each weekday so that they will have access to phones. Each volunteer will be provided with a phone, a script, an introduction, and suggested responses to various questions that had been asked in the past. Carol Johnson, Beta Alpha Psi faculty advisor, estimates the following. Number one, of the 5,000 phone numbers, roughly 10% will be wrong numbers because alumni change addresses and phone numbers without updating state university. In that case, the student is instructed to apologize to the answering party, hang up, move on to the next phone number. Each of these calls takes about 3 minutes. Another 15% will be correct numbers, but no one is home and the answering machine picks up. In that case, the student is instructed to simply hang up and move on to the next phone number. Each of these calls takes about 2 minutes. Each time an alumnus answers the phone, the student is instructed to introduce himself or herself and read the scripted introduction. The student is encouraged to engage the alumnus in conversation and reminisces about State University and bring the alumni up to date on the wonderful things that are happening in the School of Accounting. Some calls are longer, some are shorter, but the average call length is 10 minutes. Prepare a direct labor budget in hours for the fundraising call-a-thon. If 15 students volunteer, how many evenings will the phone-a-thon take? So we're going to start by calculating the minutes for the wrong numbers first. You'll remember that we were calling 5,000 folks, and roughly 10% of those are going to be wrong numbers. So multiply 5,000 times 10% and then times the amount of time it takes for these calls, which is 3 minutes. So the minutes for the wrong numbers is 5,000 minutes times 10% times 3 minutes will give you a total of 1,500 minutes that are for the wrong numbers. So that was part one. So for part two, we're going to look at the minutes for answering machines. It says another 15% will be correct numbers, but no one is home and the answering machine picks up. And that takes about 2 minutes for it to do that. So we're going to take the 5,000 phone numbers that we're calling again. We're going to multiply it by 15% that are going to be the correct phone numbers. And then we're going to multiply that by 2 minutes. So 5,000 times 15% times 2 minutes is how we get the minutes for the answering machines. The minutes for the alumni calls, the remaining phone calls out of the 5,000, you remember 10,000 was for wrong numbers and 15,000 was for correct numbers, but no one was home. So that's, if you add 10% and 15% together, it's 25% of these 5,000 phone calls that we've already accounted for. So in part 3, what we want to do is we want to take 5,000 and multiply it by the remaining 75% and then multiply it by the time it takes to do that phone call for when the alumni answers the phone, which is 10 minutes. So if we take the 5,000 phone numbers and we multiply it by 75%, because we've already used up 10% in part 1 and 15% in part 2, we have to multiply it by 75%, and then we multiply it by 10 minutes. That gives you a total of 37,500 minutes for the alumni calls. Then what we're going to do is we're going to combine all these minutes together to come up with total minutes. Once we have the total minutes, these added, we're going to divide the minutes by 60 minutes in an hour to come up with the total number of direct labor hours that the students are working. And then this total number of direct labor hours that the students are working is going to be divided by the total number of students that we have placing the phone calls, which was 15 students. And if we divide 15 into 675 hours, it means that there are 45 hours per volunteer. So each volunteer is conducting 45 hours. If we divide that 45 by 3 hours per night, because they told you that they only work from 6 to 9 o'clock at night. So if we divide that by the 3 hours that we're using per night, that will leave us with the number of nights that we are calling. And so this is a direct labor budget in hours, basically, that they prepared for you. Part 2 is a what if analysis. What if the phone-a-thon can be moved to the State University Foundation phone bank? That facility has an automated calling system that will automatically dial the phone numbers and route all answered calls directly to the students. As a result, no time is spent in dialing and listening to answering machines. That's an important part of this, answering this problem. The time savings due to having the numbers automatically dialed and routed mean that the average length of wrong number calls drops to 1 minute. That's also important to note here. And that the average length of the alumni calls drops to 8 minutes. So they want you to prepare a direct labor budget, just like we did before, in hours for the fundraising call-a-thon at the State University. And they're still using 15 students as volunteers. They still want to know how many evenings it's going to take to conduct that phone-a-thon. So the minutes for the wrong numbers would be calculated first. We would still take the 5,000, multiply it by 10%, which was the number of wrong numbers. And then you'd multiply it by 1 minute this time, because in the new instructions, they told you that it would reduce the wrong number time down to 1 minute. So 5,000 times 10% is 500 times 1 minute is 500 minutes. They also told you that no time is spent in dialing and listening to answering machines. So I just put a 0 in here. I really just copied what I did before and just putting the new numbers in over here to the side. the minutes for the alumni calls, still going to be 5,000 calls that you're making, still going to be 75% of them are actually got to speak to an alumni, but those minutes now have changed to 8 minutes. So we would multiply by 8. So 5,000 calls times 75% of those were made to alumni times 8 minutes each gives you a total of 30 minutes for the alumni calls. Then you're going to combine the wrong numbers, the answer machine minutes, and the minutes for the alumni calls together. And if you total these up, you can see that the total minutes is 30,500. We would divide it by 60 minutes in an hour, and that will give us total student hours of 508 hours, 0.3333. And you could round that most likely to at least 2 decimal places. And in most cases, I would just say it was 508 hours, but do what the instructions tell you to do. 2 places, I think, is what they wanted there. Then you're going to divide this number by 15 students to give you the total hours per volunteer, which was 33.89. And then we're going to divide that by the 3 hours each evening, and that would tell us the total nights of calling with the what if analysis. So this is just doing a direct labor budget in hours. Let's look at the next exercise, and we're going to complete an overhead budget. You'll remember from a previous recording that we said that we would prepare our budgets in an order. So you would start with your sales budget first, then prepare the production budget, and then the direct materials budget, and then direct labor budget, and then your factory overhead budget. So I want you to know that there's still an order that you prepare these budgets in. And so the overhead budget is coming next. And the overhead budget is what it says it is. It's creating a budget basically for factory overhead. In this exercise, we're going to be the Johnston Company, and we're going to clean and apply powder coat paint to metal items on a job order basis. Johnston has budgeted the following amounts for overhead categories for the coming year. So these are all of the overhead accounts that they have listed. In the coming year, Johnston expects to powder coat 120,000 units. Each unit takes 1.3 direct labor hours. Johnston has found that supplies and gas used to run the drying ovens, all units pass through the drying ovens after a powder coat of paint is applied. These units or these costs tend to vary with the number of units produced. So our supplies and our gas is going to vary with the number of units produced. These are what we would call our variable overhead. All of the other categories are considered to be fixed. So supplies and gas is variable. The rest of these are fixed overhead. In part 1, they want you to calculate the number of direct labor hours Johnston must budget for the coming year, calculate the variable overhead rate, and calculate the total fixed overhead for the coming year. When required, round your answers to the nearest cent and use the rounded answers in subsequent requirements. So the first thing that you would need to calculate is the number of direct labor hours in the budget, which should be down here on line 4. So let me get to where we can see line 4. And to find those hours, the direct labor hours, we would take the expected units produced times the time it takes to produce one unit. The expected units produced was given at 120,000 units, and then we would multiply that by 1.3 hours this was given to. That's the amount of time it takes to produce one unit. So when you multiply the two of these, you're going to get total direct labor hours at 156,000. They also wanted you to determine the variable overhead rate. And to determine the variable overhead rate, we would take the total variable overhead and divide it by our direct labor hours. Well, we don't know what the total variable overhead is, so you've got to determine that. So the variable costs are going to be supplies and gas. That was given. This was the amount of the variable cost. We're going to total up the variable cost to get 266,000. Once we know what the total variable costs are, we're going to divide that by the direct labor hours, and that will give us our variable overhead per unit. So they told us that supplies and gas were variable cost. You combine the two of those together to get your total variable cost, which is 266,000. Then we're going to divide that by the direct labor hours, and that will give you the variable cost or the variable overhead rate, I should say. And this rate was rounded to $1.71. The fixed overhead, you would list all the other overhead accounts and just total them together to get the total fixed cost. So I simply copied what they had told me from above, what our fixed costs were. I wrote those down along with their amounts and then just totaled them up, and that's your total fixed cost. Then in part two, they want you to prepare an overhead budget for Johnston for the coming year. They want you to show the total variable overhead, total fixed overhead, and total overhead. And then it says, when required, round your answers to the nearest cent. So the first thing we're going to figure is the overhead budget. And we start by taking our direct labor hours that we calculated before on cell address B4. 156,000 is the amount of the hours that we calculated right here. And so I'm just basically putting it down here again. The variable overhead rate, we calculated that to be 171 right here. So I'm just plugging that in. Now the budgeted variable overhead is going to be equal to your budgeted variable rate times your direct labor hours. So direct labor hours of 156,000 times $1.71 gives you the budgeted variable overhead at 266,760. To that, we're going to add our fixed overhead, which we'd already calculated right here. So we take this total fixed amount and bring it down here and plug it in. Then you're going to add your variable overhead and your fixed overhead together to get your total overhead, which is 698,660. Then they want you to find your fixed overhead rate. To find the fixed overhead rate, we'll take the budgeted fixed amount of overhead. The budgeted fixed amount of overhead was 431,900. We're going to divide that by our total direct labor hours, which is 156,000. So 431,900 would be divided by 156,000 to get 277,000. excuse me, not thousand, $2.77. So again, it's budgeted fixed overhead divided by your total direct labor hours gives you $2.77. Then they want you to determine the total overhead rate, which is your variable overhead rate that you already found, plus what you just found for your fixed overhead rate. The two of those together are your total overhead rate of $4.48. Then they have a what if analysis. What if Johnston had expected to make 118,000 units this time instead of the 120,000? It's 118,000. Assume the variable overhead per unit does not change. Now that's an important piece of this information to get these numbers to come out right. In Cengage, read carefully. The truth of the matter is that your variable overhead rate would change because the number of units that you produced changed. But that's not what they wanted here for whatever reason. They're just telling you to assume that the variable overhead rate does not change. So that means we're going to use the $1.71 that we found earlier as our variable overhead rate. They're also telling you that your fixed overhead does not change either. So it's going to be basically the same. What has changed is that you're producing 118,000 units rather than 120,000 units. So 118,000 units times the amount of time it takes to produce one unit, which is 1 hour and 30 or 1 hour and 30 minutes. That would give you direct labor hours as, or I said 1 hour and 30 minutes, that'd be 1.5 hours. Sorry, 1.3 hours would be multiplied by 118,000 units to get the total direct labor hours for this what if analysis. And so then they wanted you to put that back through a budget. So we start with our budgeted direct labor hours. We're going to put in the variable rate. And remember, they said that that did not change. So this was still $1.71. We would multiply that by the budgeted direct labor hours. That's going to give us a new variable overhead amount for total variable overhead of 262,314, which we're going to add to our budgeted fixed amount to get the total fixed overhead budget. And then they wanted you to calculate the fixed overhead rate and the total overhead rate. So to calculate the fixed overhead rate, we take the budgeted amount of the fixed overhead, which was 431,900, and we're going to divide that by the total direct labor hours. And this time the total direct labor hours was 153,400. So 153,400 is the overhead hours that would be divided into the fixed amount of overhead, and that will give you $2.82 as your fixed overhead rate. So your variable overhead rate plus your fixed overhead rate will give you the total overhead rate. And so for the what if analysis, the total overhead rate is $4.53. So I'm going to stop sharing this with you, and we'll see you again next time. Bye-bye.